Hello, folks. This is your confidence intervals for proportions video. So in this video, I'm going to talk you through the process that we use to actually construct and then interpret confidence intervals, all in one fell swoop. Okay. So if you haven't watched the previous video on like the basics of confidence intervals, you need to make sure that you watch that first, because that goes into a lot of the theory and like what we're doing and why we're doing it, what these critical values are, all that fun stuff, okay? But if you've watched that video, you're ready for this one. So let's just go ahead and jump into it here, okay? So first thing is, when you construct confidence intervals, there are some conditions that you have to check, okay? And I'm hoping that these look very, very familiar to you. You have your randomness condition, your 10% condition, and your success-fail condition, right? Sometimes called your large counts condition, okay? So you can see the full like written out definition on the left side of your screen, but I'm going to simplify it for you a little bit on the right side of your screen, okay? So for randomness, all you are checking is that you have a simple random sample, right? So an SRS or a randomized experiment. Okay, if you have either one of those, you've satisfied your randomness condition. Okay, your 10% condition is that your sample can be no larger than 10% of the whole population. So typically the way that we check this is we do 10 times the sample size should be less than the total in the population. Okay, and then for success fail, again, I'm hoping these formulas look really, really familiar to you because they're the same or very, very similar to the ones that you used for sampling distributions of proportions. Okay, so your success fail condition here is n p, and it's p hat has to be greater than or equal to 10, and n times 1 minus p hat, I'll have to add my hat in just a second, is greater than or equal to 10. Okay, now the reason that we're using p hat instead of p in these formulas is that we don't know the true proportion value, right? That's the whole point of creating a confidence interval, is to give us an estimate of the true proportion value. Since we don't know the true proportion value, we have to use the next best thing, which is your sample proportion, okay? So same three conditions essentially as what you did with sampling distributions, okay? Now, if we violate these conditions, if these conditions are violated, we can still go on with the problem. It's just that the capture rate, so meaning your confidence level, will be lower than what is advertised. Okay, but typically especially with free response questions that deal with confidence intervals, your conditions will be satisfied. You just have to make sure that you check them. Okay. All right. So once we check our conditions, okay, we have to follow, right, our general formula for a confidence interval, which is up there on the screen again. So it's your statistic plus or minus your critical value times the standard deviation of the statistic. Okay, now again, I'm hoping that especially your standard deviation, or technically it's called standard error, formula looks really, really similar. It's almost exactly the same as the one from sampling distribution of proportions. The only difference is we're changing p, which is the true population proportion, to p hat, your sample population proportion, because we just don't know what the true value is. Okay. Technically, like I said, we call this standard error instead of standard deviation because we're working with a sample and not a population, but that's like a minor semantic like detail here, okay? And then just as a reminder for you, we talked about this in the last video, but I want to remind you and give you an actual like definition of your critical value, all right? Which for proportions is Z star, okay? So this right here is your critical value. Okay, that's your multiplier, right? That makes your interval wide enough to actually capture what you say it's going to capture. Okay, so your critical value is the z value that corresponds to the middle, and we would say C%, so like 90% or 95%, whatever your confidence level is. Okay, the middle C% of the population in a normal curve. And then as a reminder, the larger the confidence level, the wider the interval, right? So the Z value is going to be larger. Okay, right? So again, essentially what we're doing is this makes our interval wide enough for our desired confidence level. Okay. What you see boxed in blue on the left side of your screen is the full formula for a confidence interval of a proportion. Okay, so this is the formula. So it's p hat plus or minus z star times the square root of p hat times 1 minus p hat divided by n. Okay, and I'm going to do some labeling for you. Okay, remember that p hat is your sample proportion and n is your sample size. And I got to put my little hat over my p here. Okay, so just to do some labeling for you. Okay, 1, 2, 3. So this is your standard error. Okay, z star is your critical value. Okay, and p hat is your sample proportion. Okay, and then remember, all of this that's past the plus minus sign is your margin of error. Okay, all right. Now, I mentioned in the previous video that one of the ways that your margin of error will decrease is when your sample size increases, right? So I'm hoping that looking at the standard error equation that makes sense, right? If you put a larger number in the denominator here, it's going to make this whole number smaller, thus making your interval smaller. Okay? All right. So now that you have the formula and the conditions, let's talk about the acronym. Okay? You know me, I love acronyms, right? So this is your process when you are doing any confidence interval, right? Whether it's means or proportions, it's the exact same process. Okay, so when you are constructing a confidence interval, this is the only time that I will tell you to panic, P-A-N-I-C. If you do these 5 things, then you will hit every point that you need to hit, right? You'll cover everything that you need to cover and get all of the points for constructing a confidence interval on a free response question. Okay, so here's what these individual values stand for and what to do at each level. Okay, so P stands for parameter. Okay, A stands for assumptions. Move these a little bit. N stands for name the interval. I stands for interval. Okay, and C stands for conclusion in context. Okay, so those are your 5 steps, right? And then here's what you do at each step, okay? Okay? So at your parameter step, what you do is you state the parameter we are trying to estimate in context. Okay, so for example, we are trying to find the true proportion of people voting for candidate A. Right, that's your parameter. Okay, your assumptions are your conditions, right? So what you do at this step is check the conditions necessary to construct the confidence interval. Okay, so those are your three conditions: the randomness, 10%, and success fail. Okay. N stands for name the interval. Okay, so all you're doing here is you are identifying the type of interval. Okay, and there's a couple of key questions that you want to ask yourself, okay, in order to name the interval. Okay, so like how many means or proportions are you dealing with? Okay, are you dealing with, I really should write this in another order. Hold on. So are you dealing with means or proportions? How many of each are you dealing with? Or meaning like how many samples did you take? Right? How many sample statistics do you have? Okay, are you dealing with Z or T? Okay, and is this an interval or a test? Okay, for the purposes of this unit, okay, Z will be your answer to this question, okay, because Z goes with proportions. T goes with means, okay? And then for right now, obviously we're constructing intervals. So the answer to this question would be interval, okay? These first three steps are just to kind of like lay the foundation, okay? You're like stating what you're gonna do and then making a plan for yourself, okay? The math happens here. Actually, I should do this a little bit differently. Okay. The only place that you do actual arithmetic is at the I step. Okay, so you'll sometimes hear me call it the math step. Okay, so for your interval, right, once you get to that step, what you do is you do a couple of things. One, okay, you find every time, hold on. I hate this thing. Okay, fine. It's gonna make my text a lot smaller. So first thing is you find your sample statistic, critical value, and standard deviation, right? i.e. standard error. Okay, step 2, write the interval in what I call plus minus form and interval form. Okay, so plus minus form means that you'll have like something that looks like this. Okay, and then interval form would just be your lower and upper bound. Okay, all right, and then lastly, C stands for conclusion and context. So what you do at this step is you interpret the confidence interval in the context of the problem. Okay, so we've done that, and I've given you a word formula for that already, right? So you know how to interpret a confidence interval. Okay, so those are your 5 steps, PANIC. All right, so with that in mind, let's do an example. Okay, so I usually do this bead experiment in my class where I have you all dig through physical beads Obviously, when we're in distance learning, you aren't able to do that. If you're watching this video in subsequent years, maybe we did do this experiment in class, okay? But basically what happens in this experiment is you dig through a big bucket of beads, right? And I ask you to take a sample of them and calculate your proportion of red beads in your sample, okay? So what we're gonna do here is we are going to calculate and interpret a 90% confidence interval for the proportion of red beads in this container, okay? And we only have one simple random sample that got 107 red beads and 144 other beads. And then I'm telling you that there's 3,000 total beads in the bucket. So that's like your population value, okay? So we're gonna go through the steps. Okay, so P is the parameter step. So we're estimating lowercase p, okay, which is the true proportion of red beads in the population. Okay? So that's it. That's all you have to do for the parameter step. Okay. Step 2 is assumptions. So we have to check our 3 conditions. So my first is this a random sample? Yes, it is. Okay, so all you have to say here is simple random sample stated in problem. Okay. Condition number 2 is a 10% condition. So is the population larger than 10 times the sample? Okay, so if I look up at my sample, I have 107 red beads and 144 other beads. So my total is 251. So that's my sample size. Okay, so what I'm going to do here is I'm going to do, okay, 10 times my sample size, which is 251. That is 2,510. And that is less than the total in the population, which is 3,000. So we're good there. Okay. All right, then last condition is the success fail condition. So we're checking number of successes in the sample, number of failures in the sample. Okay, now I wrote out the whole thing with n and p hat, but what I'm hoping that you'll notice, okay, especially if they give you the number of successes, like this is the number of successes. The 107, right? So your p hat value here is 107 divided by 251, right? So if you're doing 107 divided by 251, that's p hat times 251 for n p hat. These end up canceling each other out, so you just are left with the number of successes you have. Obviously, that won't happen in every problem, like if they don't give you the number of successes, but rather they just give you the sample proportion, like as a decimal, you'll have to actually go through and do this calculation, right? But you don't necessarily have to do it in this problem, right? So my NP hat is 107, which is definitely greater than 10, okay? And then my n times 1 minus p hat, and remember that's your number of failures, which this is your number of failures. Okay, so this is a great example of work smarter, not harder. Don't do all the calculation just to end up back where you started with information that they gave you in the problem. Okay, so that value is 144, which again is obviously greater than 10. And I actually, right, as I'm going through and doing this in the notes here, I have to remember to go back and put my little hat over the P each time. Okay, that's very important to do, right? Because P in itself is an actual value. It's just a value that you don't know. So you have to make sure that when you're writing all of this stuff, that you indicate the difference between P and P hat, because there is a very important difference. Okay, so, and then just as a reminder, number of successes comes from this formula, number of failures comes from this one. Okay, so that's step 2. Step 3 is to name the interval. Okay, so you have a couple of questions that you have to ask yourself, which is, how many are we dealing with, means or proportions? How many are we dealing with? Is this Z or T? And are we dealing with an interval or a test? Okay, so obviously there's only one sample proportion. Okay, and for proportions, we're dealing with Z. And obviously this is an interval. Okay, so naming the interval is a 1 proportion Z interval. Okay. All right, now that we've laid all of that groundwork, we've gotten to the math step, okay, which is I. Okay, so we need to find our sample statistic, critical value, and standard deviation. So basically you're trying to find the things that you need to plug into this formula right here. Okay, and some of those things you'll already know, right? Okay, so some of these things we already calculated, okay, but I need to convert some of them to decimals. Okay, so P hat is 107 divided by 251. That value as a decimal is 0.426. Okay, 3 decimal places is typically fine with these types of problems. Okay, I'm just going to go ahead and tell you, you can go and verify in your Z table, but your critical value, your Z star value, is 1.645. Okay, so keep in mind, this is where that comes from, right? If I have my standard normal curve here, okay, if I'm doing a 90% confidence interval, okay, I'm looking for this value right here, and it's obviously mirrored on the other side. Okay, so if there's 90% captured in the middle, then that means there's 5% in each of these tails. Okay, so I went to my Z table and I found the Z value that was as close to, that gave you a value as close to 5% as possible. Okay, and I'm telling you that that number is 1.645. You could round up to 1.65, that would be fine. Okay, all right. And then the last thing I need to do is actually calculate my standard deviation. Okay, or technically, again, this is standard error, technically. Okay, so I'm just going to label that S for myself so I don't have to write out standard deviation. Okay, so the way you calculate that is it's P hat, so 0.426 times 1 minus 0.426 all over N. Remember, N is your sample size, which is 251. Okay, and I should write that up here somewhere for you, that N is 251. Okay, and once you get to that point, just plug that into your calculator, and when I did, I got 0.0312. Okay. Okay, so now we're going to take all of that information and put it together into an actual interval. Okay, so remember, what you are calculating is this. What you're constructing is P hat plus or minus Z star times the standard deviation. Okay, so my P hat is 0.426 plus or minus Z star is 1. Oh, here, and I should move along on this side. Okay, this is 1.645, and your standard deviation is 0.0312. Okay, right? So then I'm just going to multiply 1.645 times 0.312 0.0312, and I got this when I did. So that's my full margin of error. So 0.426 plus or minus 0.051. Okay, so this right here is plus minus form. So when I refer to plus minus form, this is what I mean. Okay, and then what you have to do is actually add the 0.051 to your population or your sample proportion and subtract it, right? You have to actually do this math, like do the addition and subtraction, and that will get you your interval form. Okay, so just for you all, I'm going to write out what's actually happening, but you don't have to write this part like when you actually go and solve these types of problems. Okay, so what I'm doing to get my lower bound is I'm doing 0.426 minus 0.051. So that's my lower bound, comma, and then my upper bound is 0.4. Oops, that looks crazy here. 0.426 plus 0.051. Okay, when I actually do that addition and subtraction, I get my lower bound is 0.375, comma, and my upper bound is 0.477. Okay, so this right here is interval form. Okay, so when I'm talking about interval form, this is what I mean. Like literally, it's just written with the lower and upper bound. Okay, one thing I want to mention that I don't think I have mentioned as of yet is that these bounds are always with parentheses, not with brackets. Okay, so we're not ever including that final value like for lower and upper bound. So it's always within parentheses, because I get people that ask me that every year. Okay, so that's the math. Okay, and then my last step is my conclusion and context. So we're interpreting our confidence interval. So for that, we're going to go back to our word formula, okay, which is we are blank percent confident. So it's 90% here, 90% confident that the interval, and then you can just put your lower bound to upper bound. So you can either write the word the interval and then just write your interval in interval form, or you could say the interval from and then just list your lower bound to upper bound. Either way would be fine. So we are 90% confident that the interval 0.375, comma 0.477 captures the true, and then you list your parameter in context, right? So that's why I have you state the parameter at the start. All you have to do when you get to the last step is copy what you wrote up here at the top. So it captures the true proportion of red beads in the population. Okay. All right, and then my very last step here, this is not a step that necessarily will be included in every confidence interval. Like once you get through the last letter of your acronym, you're done creating and interpreting your confidence interval. But every once in a while, you'll have an extra question like this where it asks you to evaluate a claim based on your interval. Okay, so this teacher claims that 50% of the beads in the population are red, right? And this says, use your interval to comment on this claim. Well, 50% is not in our interval. Remember that the interval you made is supposed to capture all plausible or possible values for the true population proportion. Okay, so if someone claims something is true that is not in your confidence interval, then you have a pretty good amount of evidence that their claim is false. Because remember, you made your interval and you said, I'm like at least 90 or 95% confident that my interval is correct, that the true value lies somewhere in that interval. Okay, so all I would say here is that because 50% is not in our confidence interval, right? So 50% is not in our confidence interval. So we have reason to believe the teacher's claim is false. Okay? All right. So that is a full confidence interval problem. All right? I have one more for you, but I want you to try this one on your own. Okay? Give this a try. Okay? So let me really quickly put all of the steps on the screen for you. Okay? So here, we're talking about a Gallup poll. You have a random sample of 439 US teens from age 13 to 17, and they were asked whether they thought that young people should wait to have sex until marriage. And then in this particular sample, 246 said yes, the others said no. And the question here is to just construct and interpret a 95% confidence interval. Okay, so go through the 5 steps, PANIC, right? And then use your interval to evaluate the claim at the end. Okay, so go ahead right now, pause the video, try this one out on your own, and then check back with me to see how you did. All right, folks. So I'm actually going to make this a little bit larger here. Zoom in on this a little bit so that you can see a little bit better what I did and what I wrote. So here is your complete confidence interval. Okay, so for parameter, we are estimating P is the true proportion of all teens in the US who answer yes when asked if you should wait until sex, you should wait for sex until marriage. Right, so that's your parameter value. You obviously could have worded it or phrased it a little bit differently, but as long as you got the gist, you're good. Okay. A is assumption. So I need to check my conditions. So first condition, random sample. Yes, it's stated in the problem. They say SRS in the problem. Okay. Second, 10% condition. Is my population larger than 10 times the sample? So I did 10 times 439 because that's my sample size. So that's 4,390, and that's definitely less than the total number of teens in the US, right? Honestly, that's probably less than the total number of teens in, like, between Valley and its surrounding middle schools, okay? Third condition is success fail. Do I have a large enough sample? So now here, they gave us the number of successes and the number of failures. They gave us that the number of successes was 246. So I'm not going to go through and like do all the calculation. I'm just going to say my number of successes is 246. That's definitely greater than 10. Then my number of failures is my sample size minus my number of successes. So that's where 193 came from. Both of those are obviously greater than 10. Okay. N, name the interval. So far, all we've dealt with is 1 proportion Z intervals. Okay, we're not going to deal with 2 proportion until we get to like section 4. When we're talking about like a difference of proportions. So for right now, we're sticking with a 1 proportion Z interval. Okay, so you've laid the groundwork. Now you've gotten to step 4, the interval. This is where you actually do the math. Okay, so you need, in order to fill in everything in your formula for the confidence interval, you need P hat, you need Z star, and you need your standard deviation. So P hat is 246 divided by 439, which is 0.56. Z star for 95% is 1.96. Honestly, that's one I would just memorize, okay, because you're going to use it a lot. And then your standard deviation, I have calculated there. I got 0.0237. Okay, once you have all that information, plug it into the formula for the constructing your confidence interval. Now, one thing I have not mentioned up to this point, which I probably should have, is you do not have to memorize this. Okay, this formula for your confidence interval is given to you on your formula sheet. Super awesome, right? And you're going to find that for most of these inference problems, they're going to give you all the formulas you need. What's more important is that you know how and when to use them. Okay, so once I have my 3 values that I need, I'm just plugging them into that formula. So I have 0.56 plus or minus 1.96 times 0.0237 1.96 times 0.0237 is 0.046, and I rounded. Okay, so that kind of third line that you see, this guy right here, is your plus minus form of your interval. Okay, and then I actually did the addition and subtraction and got a lower and upper bound. So my final interval is 0.514 to 0.606. Okay, so that's in interval form. All right, then my very last step is my conclusion and context, and this is where you whip out your word formula. So I wrote this one slightly differently than the first example so that you could see like the two ways that you can write the actual interval. Okay, choose whichever one makes the most sense to you. Okay, but you're just following your word formula here. Okay, you're just filling in these blanks. We are 95% confident that the interval from lower bound to upper bound, 0.154 to 0.606, captures the true proportion of, and then it keeps going, right? So that's your parameter and context. True proportion of teens in the US who answer yes when asked if you should wait for sex until marriage. You can literally just copy exactly what you wrote in the first step. Okay, that's genuinely one of the only reasons that I make you write it out, right? And that's really one of the reasons that AP wants you to write it, so that they know that you know what you're looking for, okay? And then my final thing here is we have a newspaper that claims that 60% of teens believe young people should wait to have sex until marriage. And they want us to use our interval to comment on this claim, right? Well, 60% is in our interval, right? So that is a reasonable claim, right? Because remember, our interval is supposed to capture all plausible or possible values of the truth. So since 60% is in the interval, it is a plausible value of the truth, right? So that's basically what I said when I answered the question. Because 60% is in the confidence interval, there is evidence to support the newspaper's claim. All right, y'all. So that's essentially it for confidence intervals. There's one more like short video where I'm going to talk to you about choosing a sample size. This shows up every once in a while in free response questions. It shows up every once in a while in multiple choice questions. So it's good to know how to do this and how to like manipulate the information that you have to figure out like a minimum sample size. So that's the last video in this section, right? That one will be short, much shorter than the past two have been. All right. So I will see you all in the next video. Bye, everybody.